We're in Precalculus lesson 3-8. Today is Friday, December 7th.
The date's wrong.
It is wrong? Oh my gosh. Yeah, extra credit point. We went through how many classes without anyone finding that? Good job. So Friday, December 7th, 12/7. I will fix that in a sec. Daisy, log it in your extra credit tracker. That's easy extra credit points right there. All right, so today we're trying to use magnitude and direction to get to component form. And by the way, component form, we've been dealing with it for this entire unit for 7 lessons now. So component form, what is that?
Thank you.
What is component form, Daisy or Rochelle? What is component form? You remember? It's this thing where you can have an x comma y. It's this thing where you can have something like, I don't know, 2i with a cap plus 7j with a cap. That's component form, where you have an x and a y given to you, and it's just, it's the x and the y. There's no magnitude and direction. So I want to get to this form today from magnitude and direction. All right, so let's assume that we know the magnitude and direction of this line. So we have an angle. We have some theta. We know what that angle is, and we know how long that line is. Let's call this vector vector u. So we happen to know what the magnitude of u is. It's just given to us. How do we go about finding how long the x and y are? How do I derive this length here and this length here? Maybe I can use technology to make those nice. How do I find that and that? I mean, it's easy from the graph. You can just look at it graphically and say, okay, well, the x direction is 6, the y direction is 5. But how would you do that if you didn't know from the graph? How could you use trigonometry to find that? If I know what the magnitude of u is and I know what the angle is, how can I use that to find x? SOHCAHTOA, exactly. So SOHCAHTOA, and we can write that down on the side notes again. So SOHCAHTOA. And we'll label this one again. Which one is going to be our O? Which one of these 3 sides is O? Short leg over here, yep. And then A must be that one, and then H is this one. Okay, so if I'm given the hypotenuse, it tells you how long that is. We know the magnitude of vector u. If we know the hypotenuse and we're trying to get opposite, which of these trigonometric functions am I going to be using? It's not going to be tangent, you're right. But if I want to find this one, not this one, but this one, it's going to be O and H, so I'm going to be using sine. Yep. So to find this leg right here, I'm going to say sine of whatever angle I was given is going to be equal to, and then I have to do over H. So I have to say our missing leg here, and I'm just going to call that O. Let's call it our Y, actually, because it is the Y direction. This is Y, and this is X. So that's going to be Y. All of that is going to be divided by our magnitude of u. All right, so Rochelle worked with me to do that one. So Daisy, you're working with me for the next one. I want to find x. I want to find this adjacent side. How am I going to use trigonometry to find it? I have an a that I know, and then an a that I want to know, this x that I want to know, and then I'm given h and theta. So how can I use h and a to find a trig function? Which trig function am I going to use? Cosine. And tell me what's right. Cosine of what? Cosine of theta, yep, is equal to a, which is x, yep.
X, sorry, yeah.
You're good?
Over the u vector?
Yeah. So what do we call this thing? So it's the u vector, but the thing on the outside is called the magnitude. Yeah, the magnitude of u, which is just a number. It's just the length of it. Perfect. And that's essentially what you need to do to find your formulas. So your formula's down here. X is going to be equal to, well, to get x by itself, I need to multiply this u magnitude, the magnitude of u to both sides. If I multiply the magnitude of u on both sides, the u goes away, and I'm left with magnitude of u times cosine of theta. Is that, you see that?
Wait.
Okay, so I'm trying to find x right now. I'm trying to find x. So to find x, I need to multiply both sides here by the magnitude of u. Multiply by the magnitude of u. Yeah, so x is equal to cosine theta times the magnitude of u. Let's write that down. X is equal to the magnitude of u, or whatever vector you're looking for, and I multiply that with cosine of theta. All right. Then what is y going to be? There it is, magnitude of u times the sine of theta. And this kind of makes sense with what we know too, because I've told you from unit 1 that cosine, well actually it was unit 9 from algebra 2 when we reviewed, that cosine is the x and sine is the y, and that kind of makes sense here too. Sine goes with the y, cosine goes with the x. It's just something that we've already memorized, and hopefully it's easy to remember that now. So take the magnitude of u, multiply it by cosine of theta. Here's why that makes sense in a different light. So a unit vector has a length of 1. So essentially what this is saying is look at the direction of the unit vector. So the unit vector looks right here. And then once I find what direction I'm going in, go ahead and multiply it by the length to get it to the correct length. Multiply it by this length here, the magnitude of u, to get it to the correct length. That's another way of seeing this problem. Let's use our two formulas that we've derived to do 3 examples. We have example 1, 2, and 3 in the back. So, example number 1. This vector right here, this blue vector, is vector u. I want the component form of u. I know that the magnitude, the length, is 5, and that the angle is 65 degrees. How am I going to find the component form? Well, I'm going to use my formula, so tell me what to write. Rewrite one of these formulas. Which one do you want to do first? Cosine of 65. There it is. And we'll eventually get an approximation for that, and we need y as well. Daisy, what's y?
Wait, why? Oh, we're trying to find both?
Yep, we need an x and a y, because that's the definition of component form. You have an x and a y.
So there would be y equals 65 times cosine.
Careful, careful. Because cosine of the angle, right?
Oh, I mean sine.
So say it all one more time.
So y equals 65 times sine of 5.
Like that. Remember that this is our theta that goes inside your sine. So this is our angle that goes inside the sine. So it should be sine of 65.
Oh.
So let's come back here. Say it one more time.
Y equals 5 times
Come here.
sine.
There it is, yep. And I'm writing approximately equal to because we're going to get some decimals and we're going to round to the nearest thousand. All right, you both have calculators next to you or in between you. You can use those calculators. You can use your phone calculators if you want. I get negative 2.81. Is that what you two get as well? Or that's probably in radians, huh? That calculator is by default radians. Let me. I think I need to go to the calculator app, so I'm in degrees. So I'm now in degrees. So let me try this again. 5 times 65, and then I have to cosine that. 2.11. Yep. All right. Nice. So it is approximately equal to, and we can do this in red. 2.11. All right. What about when I do sine? So another way of doing it is I can clear this. I can hit 65 first, and I do sine of that, and then I multiply that by 5. That's cool. Oh, sorry, I got distracted. 65, I do sine of that, and I multiply by 5. So do you get 4.53? 4.53. All right. And those are our final answers. So that's our component form. We would write this as 2.11, comma, 4.53 in parentheses and box it. Oop, that's not my box. There's my box. Notice that there's no checking what quadrant you're in. You don't have to worry about that. You literally just plug it into the formula, and you're good. You want to try example 2 together, or do you think you're good? Eventually, you're going to do one of them by yourself. You're definitely doing 3 by yourself. But do you want to do 2 together or by yourselves? Nothing? Okay, so let's do this. You two do example 2 together, and then do example 3 independently, and then check your work on example 3. All right, example 2, answer was 4, comma, negative 6.93 when we round. Thumbs up, thumbs down. Rochelle? Yep, all right. Example 3, answer was negative 2.82, comma, negative 1.03. Thumbs up, thumbs down. Uh-oh, what happened? 2.82. Okay, we can check again. Calculator.app. So 200, when we do cosine of that answer, and we multiply it by 3, we do get a negative 2. And another way to check your work too is this x direction should be a negative x direction since we're going to the left. Oh my gosh, I apologize so much. So I do get a negative 2.82 on my calculator. And just another way that you can check is since this vector is going in the negative x direction, we should have a negative x here.
Negative 2, it's just there's something right here.
Oh, the calculator. Yeah, okay. All right, cool. Go ahead and write your summaries and then begin on Khan Academy.